So we have our task 5 now, and here we are again supposed to find out the eigenvalues and eigenvectors of a given matrix, but this time it is a 3 by 3 matrix using the determinant method. So let's get started. At first we have to use the characteristic equation to find out the eigenvalues. So we have our characteristic equation, determinant of A minus lambda I is equal to 0, and this will help us getting our eigenvalues. So first let's do this part of the equation, which is A minus lambda times I. So you have your matrix A here, minus lambda times the identity matrix. The 3 by 3 identity matrix looks something like this here. So you have 1 0 0 0 1 0 and 0 0 1. So the ones are in the diagonal and everything else is zeros. And then if you try to solve this, you will have here your A minus the lambda when it multiplies inside here. So when the lambda multiplies with 0, it's 0. When the lambda multiplies with 1, it's lambda itself. So you have your lambda times 1 is lambda, lambda times 0 is 0, 0, 0 here, lambda times 1 is lambda again, and so on, and lambda times 1 is lambda. Now if you subtract this to here, you will get 4 minus lambda, and you have here minus 2 minus 0 is minus 2, 2 minus 0 is 2, and 0 minus 0 is 0, 0 minus lambda is minus lambda, and 0 minus 0 is 0, and then you have 1 minus 0 as 1. Again, 1 minus 0 is 1, and 1 minus lambda is 1 minus lambda. So now we'll do our determinant part here. So let me copy this to the other page so it's easier. So now we'll have to find out the determinant of this matrix here. And to find out the determinant, you have to use the first element here times the determinant of this matrix here on the other side, leaving the row of the element and the column of the element here. So you don't do anything with the row of the element and the column of that element. So we'll have here, and it will be positive at first. So we have 4 minus lambda times the determinant of this is minus lambda times 1 minus lambda minus 0 times 1, and then the next value will be negative. So keep this in mind, the first one is positive, then we have negative, and so for the first element it will be positive here. So for the first element it will be positive, for the next element it will be negative here, and then for the next element again positive. So here now we have negative 0 times, I won't write what is here because 0 times anything will be 0, but I hope you know that when I take the 0, I'll be finding out the determinant of the elements of this column here and this one here, because I'll be deleting everything in that row and in that column. So the left out elements is minus 2 and 2, 1 and minus 1 minus lambda, and I'll find out the determinant of that. But here I'm not writing it, or maybe let me write it down. So this one here will be minus 2 times 1 minus lambda minus 2 times 1. Okay, the reason why I did not want to write this is because when you multiply with 0, it will automatically become 0 here. Now for the next one, we'll have here plus and plus 1 here. So we take the 1 as the element now, and we, without looking at its row and its column, we'll take all the other elements and find out the determinant of that. So here we'll have minus 2 times 0 minus, we have here minus lambda times 2. So now if you solve that, we'll get here 4 minus lambda times minus lambda times 1 is minus lambda, and minus into minus is plus lambda squared, and here 1 times 0 is 0, so we don't need to write that. Minus, we have everything here is 0, and then we have plus 1 times this is 0 here, so we have minus times minus is plus, so plus lambda times 2, so that would be here as 2 lambda. And if you open the brackets here, you will have minus 4 lambda plus 4 lambda squared plus lambda squared minus lambda cubed plus 2 lambda. And now if you simplify that, you will get here minus lambda cubed plus 5 lambda squared and minus 2 lambda is equal to 0. So now what we can do over here is we can take out minus lambda as common, and then we'll have here lambda squared minus 5 lambda plus 2 is equal to 0. So it becomes more simple for us. We can solve this quadratic equation using the formula we have. So we'll get here, let's do it maybe here at this corner. So we have here minus b is minus 5 plus minus square root of b squared, so b is minus 5 squared, minus 4 times a is 1 times c is 2 divided by 2 times a is 1. So that gives us 5 plus minus square root of 17 divided by 2. So we can say here that or let's write it all together this side here. So we have here minus lambda, so here we have minus lambda is equal to 0, and when we, so if we can write it as lambda is equal to 0 here, and let's say this is lambda 1, and then when we solve this quadratic equation and we get it to 0, we get these values here. So we have for 1 lambda, let's say lambda 2, we'll have 5 plus root 17 divided by 2, and for another lambda, let's say lambda 3, we have 5 minus root 17 divided by 2. So that's our 3 eigenvalues here. So we have lambda 1, lambda 2 and lambda 3. Now we will start working for our eigenvectors for these 3 lambdas. So we will start by solving the equation, that is a minus lambda I times the x vector is equal to 0 vector for, let's say, lambda is equal to 0. So first let us solve this part here. So we have a minus lambda is 0 times the identity matrix. So 0 times the identity matrix will be 0, and a minus 0 will be a itself. So we'll have here 4, 0, 1, minus 2, 0, 1, and 2, 0, 1. And now what we can do is we can make this to reduced row echelon form. Unlike the previous one, in task 4 I have done it to row echelon form, not reduced row echelon form. In reduced row echelon form, the first element of every row should be 1, and the row that has no non-zero element, or the row that has all zeros, it will be at the end of all the other rows. So let's make this to reduce row echelon form here. And for that, the first row operation we can do is we can take here, we'll take row 1 and divide it by 4 and put it in row 1. So that will give us the first element to be 1 here, and then we have 0, 1 over 4, and here we have, as we had everything like before. And then now we can carry out our next row operation, which is row 3, no, sorry, row 2 minus 2 times row 1, and we'll keep the values in row 2 now. So this gives us the matrix, which is 1, 0, 1 over 4, and then we have here 0, 0, 3 over 2, and 2, 0, 1. Now if we carry out the row operation here as row 3 minus 2 times row 1, and we keep the values in row 3, this gives us here 1, 0, 1 over 4, 0, 0, 3 by 2, and then we have here 0, 0, 1 over 2. And then we can do the row operation, row 2 divided by 3 over 2, and put the values in row 2. That will give us 1, 0, 1 over 4, and then we have here 0, 0, 1, and 0, 0, 1 half. Now the next row operation that we can do is row 3 minus 1 over 2 times row 2, and put the values in row 3. So that will give us 1, 0, 1 over 4, 0, 0, 1, and 0, 0, 0. So that's, we have received our or we have arrived at our reduced row echelon form now. Here, or not yet, we have to do one more step. So here we have row 1 minus 1 over 4 times row 2 minus, sorry, we put the values in row 1, and that will give us 1 0 0 0 0 1 and 0 0 0. So now if we use this here for our equation, so we have here 1 0 0 0 0 1 and 0 0 0 times x1 times x2 and x3 here is equal to 0 0 0. So here we can see that x1 is equal to 0, and we can also see that from the second row we have x3 is equal to 0. But then for x2 we have no information given for x2. So in that case x2 is a free variable, and let's say, or let's choose for x2 the number 1 in this case, and then we'll have the solution vector. Maybe I'll just write it here, so, or it's congested, so I'll just write another page here. So the solution vector for the lambda is equal to 0 we have is 0 1 0. Okay, now let's find out the eigenvector for the lambda 2, which is 5. So what was our lambda 2 again? 5 plus root 17 divided by 2. So we have here 5 plus root 17 divided by 2, and let's find out the eigenvector for that. So we have to again solve the equation, which is a minus lambda I times x is equal to 0, and solving this part here first, we have a minus the value of lambda is known to us now, which is 5 plus root 17 divided by 2 times the identity matrix. So we'll have here if you solve this, you will get three minus root 17 divided by 2 minus 2 and 2, and here you have 0 minus 5 minus root 17 divided by 2, and here we have 0, and then we have 1 1 and minus 3 minus root 17 divided by 2. So now if we solve, or we try to make this into the reduced row echelon form, it is a bit lengthy here. So the first operation will be row 1 divided by 3 minus root 17 divided by 2, and we'll put the values in row 1 here. So we'll get the values as 1, 0, minus 3 minus root 17 divided by 2, sorry, divided by 4 here. And then we have here minus 2 minus 5 minus root 17 divided by 2, 1, and here we have 2, 0, minus 3 minus root 17 divided by 2. And then we can carry out our next row operation, which is row 2 minus 2 times row 1, and we can put the values in row 2. This will give us 1, 0, 2, 0, minus 5 minus 17 divided by 2, then 0 here, and here we have minus 3 minus root 17 divided by 4, and we have 1 and minus 3 minus root 17 divided by 2. So I've done a mistake here. So we have here minus 5 minus root 17 divided by 2, and here it's not supposed to be a 1 here. So we have here minus 1 minus root 17 divided by 2. Okay, so we have made the leading element in our first matrix here. So we first made this one to 1, and now our target is to make then we have made the second row first element to 0, and now our target is to make the leading element of the second row as 1. So we will take the operation row 2 divided by minus 5 minus root 17 divided by 2, and we'll insert the values to row 2, and this will give us the matrix 1, 0, minus 3 minus root 17 divided by 4, and then we have 0, 1, 3 minus root 17 divided by 2, and then we have 0, 0, 0, okay. Now that's it. So the leading elements are ones of the rows that are non-zero, and the row that is all zeros is at the bottom. So now we have 1 times, or let me write this matrix again or copy it. we have the matrix times the unknown vectors x1, x2, and x3 is equal to 0, 0, 0. So here we have 1 times x1 plus minus 3 minus 17, sorry, root 17 divided by 4 times x2 is equal to 0. So we can say that, no, that's x3 here. So we can say that x1 is equal to three plus root 17 divided by 4 times x3. And now let's choose x3 to be equal to 1. So in that case we'll have x1 will be equal to 3 plus root 17 divided by 4. So that will be the value for x1 then. And then for the next equation here we have 1 times x2 is equal to, sorry, not equal to, plus we have minus 3 plus root 17 divided by 2 times. So this is for the second equation here. So we have 1 times x2 plus I think I wrote here wrong here. So this should be minus 3 plus root 17 divided by 2. So we have here minus 3 plus root 17 divided by 2 times x3 is equal to 0. So x2 is 3 minus root 17 divided by 2 times x3. So we considered x3 to be 1. In that case x2 is 3 minus root 17 divided by 2. So that's the value for x2 now. And therefore the solution vector x for second eigenvalue will be x1 is 3 plus root 17 divided by 2. And then we have 3 minus root 17 divided by 2, and x3 is 1. Now we'll calculate for lambda is equal to the lambda 3. So for lambda 3 is equal to 5 minus we have for lambda 3, which is 5 plus, I guess we found out just now, for lambda of 5 plus root 17 divided by 2. So now we'll work for 5 minus root 17 divided by 2. The eigenvector we'll find out now for this. So we have to solve the equation a minus lambda I times x vector is equal to 0 vector. So solving this part here will, so a minus the lambda 3 is 5 minus root 17 divided by 2 times identity matrix. This gives us the matrix here, 3 plus root 17 divided by 2, 0, 1, minus 2, minus 5 plus root 17 divided by 2, 1, and then we have 2, 0, minus 3 plus root 17 divided by 2. So this one here, if you're trying to make it into the reduced row echelon form, so first we'll try to make the first element here as 1. For that we have to do the row operation, row 1 divided by 3 plus root 17 divided by 2 times, we put the values in row 1 for this. So this gives us the matrix 1, 0, minus 3 plus root 17 divided by 2 divided by 4, and then we have here minus 2 minus 5 plus root 17 divided by 2, and here we have 1, then we have 2, 0, and minus 3 plus root 17 divided by 2. So now we will try to make this element here 0, because below the first element of the first row everything else should be 0 here. So we'll try to make the second row first element to be 0 now, and for that we'll do the row operation, row 2 minus 2 times row 1, and we'll put the values to row 2. So that will give us the matrix 1, 0, minus 3 plus root 17 divided by 4. Then we have here 0, minus 5 plus root 17 divided by 2, and here we have minus 1 plus root 17 divided by 2, then we have 2, 0, minus 3 plus root 17 divided by 2. Now we'll try to make the center element here to 1. So in the second row the first element should be 1 for the reduced row echelon form here. So for that we'll do the row operation, row 3 minus 2 times row 1, and we'll put in the values to row 3. That will give us okay, for this step we are not doing this part here, we are just trying to make this element here to be 0 now. So what we get now is 1, 0, minus 3 plus root 17 divided by 4, and 0, 0. Here we have minus 5 plus root 17 divided by 2, and then we have minus 1 plus root 17 divided by 2, and here we have 0 and 0. So now in this step we'll try to make this element to be 1, and for that the row operation should be row 2 minus root 17 minus 5 divided by 2, and we'll put in the values to row 2, and this will give us the matrix 1 0 minus 3 plus root 17 divided by 4, and then we'll have here 0 1 minus 3 minus root 17 divided by 2, and 0 0 0. So we have reached the reduced row echelon form here, where the leading element of every row is 1, and the leading element of the second row is having is at the right hand side of the leading element of the first row, the row before it, and the row with all zeros is at the bottom. So those are the rules for the reduced row echelon form. And now we can see that we have 1 times, or let me copy the matrix here. So we have the matrix times the unknown vector x1, x2, x3 equal to the 0 vector 0 0 0, and now we will have 1 times x1 plus, we have here minus 3 plus root 17 times, or divided by 4, times x3 is equal to 0. So we can say that x1 is equal to 3 minus root 17 divided by 4 times x3, and now let's choose x3 to be equal to 1, and in that case we'll have our x1 to be equal to 3 minus root 17 divided by 4. Now if we look at the second equation here, we have 1 times x2 plus, we have minus 3 minus root 17 divided by 2 times x3 is equal to 0. So we can say that x2 is equal to 3 plus root 17 divided by 2 times x3. So as we know, we have chosen that x3 is equal to 1, so we'll have x2 is equal to 3 plus root 17 divided by 2. So now we can write the solution vector. It is, for x1 we have 3 minus root 17 divided by 4. For x2 we have 3 plus root 17 divided by 2, and x3 is equal to 1. So we have got the eigenvector for the third eigenvalue here now.